Good morning, students. Now we are in the 9th class physical science subject. Second lesson, motion. The lesson name gives us the objects are said to be in motion or rest. First, what is meant by object? An object is nothing but it is a matter. In first lesson we completed what is meant by matter. Matter is nothing but anything occupies space and has mass. It is called matter. So that matter, that object can be in a rest position or motion. How can we decide? Before going to that, we should know about the word relative. So for better understanding of the relative, we can first general example we can see in our life. Real time example. Nothing but the people are in motion, the vehicles are in motion, the earth also it is in motion, the moon also it is in motion. Due to the reason of earth it is in motion, sunset, sunrise and changes of season etc. can be occur. The moon also it is in motion. Then only we can feel new moon day and full moon day. So these all are relating to the motion of the object. So we have to know about the word of relative. Before going there, he given in our textbook some of the examples. What are those? Left to right, up or down, shorter, longer, slow, fast. These all are combination of words. Sir, how can those helpful to us to know about motion or rest of the object is nothing but first we consider one of the example of left and right. Once you observe, once you imagine three students are sitting in a bench A, B, C. Three students are sitting in a bench, are sitting in a row A, B, C. The B student observing A student, he is right side of him, and the C student is left of B. Depends on A is right of B, C is left of B. It depends on the observer. Who is the observer here? B is the observer. In this way, the observer can be taken the up or down position, shorter and longer, slower, faster, slower or faster. These all are depends on the observer. So these are relative to an observer. We can confirm here. We can finalize. So same as this in this way, the motion or rest of the object. Those are relative to an observer. When the object is said to be in rest, when object cannot change its position, then the object it is in a rest position. But when it is said to be motion, when an object position is changing continuously with time relative to an observer, it is called the object is said to be in motion. We can feel different type of motions. We can see different type of motions. But what is meant by the motion? Some of the other quantities are helpful to us to know something about the motion. In those, the two important quantities, what are those? Distance and displacement. For this, we do some small activity. What is that? When we throw any object into the air, nothing but any stone thrown into the air, it traveled some distance and reached to the other point on the ground. See, I just plotted a graph for the stone throwing into the air, and it started from A and traveled into the air and covering some distance and reaching the point B, which is on the ground. Once you observe here, it is the actual path. What is that? A, S, B. It is the actual path of the stone. But the point, the stone where it started and where it reached, and just joining the line, joining the 2 points by a straight line, it is called AB. And here why I plotted a graph means ASB is the distance and AB is the displacement. Once again, ASB is the distance, AB is the displacement. But how can we define? Distance is nothing but the actual path covered by an object. The actual path covered by an object in a given time interval, it is called distance, and displacement is nothing but the shortest distance covered by an object in given time interval, it is called displacement. But why I written here scalar and vector? First, in the physical quantities, what is meant by scalar quantities and the vector quantities? Scalar quantities, nothing but some of the quantities having only magnitude but no direction. Then those are called scalar quantities. But some of the other quantities having magnitude along with direction, those are called vector quantities. How can we represent? The scalar quantities are represented as only a line, and vector quantities line along with one arrow head. These is the symbols for scalar quantities and vector quantities. And here ASB is the distance and AB is the displacement. These two quantities are time dependent quantities. Means any object is said to be in motion, though that object may having two quantities. We can measure the distance and displacement with respect to time. Without time changing, we cannot experience anything in the universe. So, time dependent quantities, these two are. And what are the units of distance and displacement? The words distance and displacement, those are simple lengths. So, the units are kilometers, meters, centimeters, or millimeters. It is simple about distance and displacement. Once take another activity. A train started its journey from Vizag to Hyderabad via Vijayawada. And when it started 5 o'clock in the evening, and when it reached 5 o'clock in the morning, how many hours it traveled? 12 hours. Yes. And what is the path? Once you observe, how is the path Vizag to Vijayawada and Vijayawada to Hyderabad? The curvy lines, nothing but it is not a straight line. It is the actual path covered by the train. And once you observe here, these are the dashed lines. This dashed line gives us the displacement between the Vizag and Vijayawada. This dashed line, these dashed lines represents us displacement between the 2 points. Why? Because this is the shortest path. So we covered how much distance? Actually 720 kilometers. But when we assume what is the assuming distance between shortest distance between Vizag to Hyderabad, directly we cannot travel in this way, but we can assume what is the distance? 360 kilometers. How much time we traveled? 12 hours. Then here we can take two other definitions. What are those? Average speed and average velocity. What is meant by average speed? Average speed is nothing but the total distance covered by an object in unit time is called average speed. Here, how much distance is covered? 720 kilometers. What is the time? 12 hours. Then we calculated average speed. What is it? 720 by 12. How much? 60 kilometer per hour. It is the average speed. But what is meant by average velocity? Average velocity is nothing but the total displacement covered by an object with respect to unit time is called average velocity. Here, what is the displacement we assume? 360 kilometers. And what is the time? Time is constant for 2 points, distance and displacement, 12 hours. So 360 by 12. How much? 30 kilometers per hour. Along with the direction here. What is the direction I mentioned here? South-west. So average velocity, average speed. And which is scalar, which is vector quantity. Average speed is related to distance, so that's why it is a scalar quantity, and average velocity is related to displacement, so it is a vector quantity. Otherwise, here, what is the answer here? 60 km per hour. We have only magnitude, and here we have magnitude along with the direction. So this is a vector quantity, and average speed is a scalar quantity. And here, most of the physics problems having some conversion methods. What are those? Conversion. To our convenient way, the distances can be converting kilometer per hour to meter per second, or meter per second to kilometer per hour. How do we convert? What is the way? Simple. Kilometer per hour to meter per second, we have to multiply the given value with 5 by 18. In case of meter per second to kilometer per hour, the given value should multiply with 18 by 5. This is the way of conversion of lengths or any distances. Now, another activity. When you imagine 2 points in our playground, what are those? A and B. The 3 number of students are standing at A point, and the B point is a destination. Nothing but the three number of students can cover some distance and reaching to the point B. What is the distance between the 2 points? 50 meters. Every student should cover 50 minutes. But what is the condition? There is no condition. Any student can their own way. But they should reach B point. What is the way? A can travel in this way. And how much time will taken? 20 seconds. And here B, 10 seconds he covered. 10 seconds he covered 15 meters and reaching to the point B. C also same way. And here the paths are not linear and the different paths. A student covering different path, B and C. These three number of students cannot follow the same path. So just we calculated it is a distance covered. So average speed of first student, second student, third student. What is the formula? Distance by time taken. Here 50 by 20, 50 by 10 and 50 by 25. Who has more speed, more average speed? Second student has more average speed and he is the faster. And the same activity, the same number of students between the same 2 points. But here the condition is three number of students should travel in a straight line. How can they travel? So these are the parallel lines between the 2 points. What is the distance between of them? 50 meters. And here these parallel lines gives us the shortest path between the 2 points. Shortest 50 meters. So first student 20 same as it is. Second student covering in less time, 10 seconds. 10 seconds he covered 50 meters. So second student has average velocity is high. And among of these three, second student is the faster student. What is the difference between the two examples, two activities? Nothing but here we consider is the distance. Three number of students covering the distance in their own way. But here three number of students traveling in a straight lines. So measuring of average speed and average velocity. These two are helpful to us. What type of motion it is, and but these two cannot give us any particular instant of time. So once again we can take what is the speed and velocity. What is the speed and velocity? Now we can take about what is speed and velocity of an object. We clearly mention here one of the object can cover some distance with respect to time. First we can take the graph, plotted a graph between the distance and time. Distance can be taken on y-axis, time on x-axis. Here how many distance? S1, S2, S3 and T1, T2, T3. Why mentioned here? And whenever we drawn one of the perpendicular lines of S1 to T1 and S2 to T2, S3 to T3. And what is meant by the average speed? Before going to that, here what is mean by measuring devices of speedometer and odometer? These two are the measuring devices. Speedometer is used for to measure the speed of the object at any particular instant of time. It is helpful. Speedometer used for the speed of object at any particular instant of time, and odometer is used for to measure the particular distance of the object. These two are the measuring devices. Keep in mind, students. And then here we observe the slope is started from the origin and reaching to the intersecting points of object S1 to T1 and S2 to T2 and S3 to C. It is called slope of the object. Slope of the object. Slope it gives us the speed may be gradually increasing or decreasing. Find the average speed of the object when it started from S1 and reached to the point S2. So what is the final point? S2. The covering distance is S2 minus S1, and what is the time interval? T2 to T1. T2 minus T1. So average speed is calculated by S2 minus S1 and T2 minus T1. Where the speed is high or low. Here you observe so many points on the slope. Where is the speed of the object is high or low? Depends on the slope of curve. Depends on the slope of the curve. Where the slope is high, the speed of an object is high. Where the slope is low, then the speed of the object is low. So, but here, what is the importance of T3 here? The difference between the distance between T2 and T3 is very short. Nothing but for a very short period, nothing but 2 seconds to 3 seconds, 2 seconds to 3 seconds or 2 seconds to 5 seconds, it is called as a short period. For a short period, cannot change the average speed. Whenever the object covering from 1 second to 3 seconds or 1 second to second, that object average speed cannot be changed. So keep in your mind, for a short period of time, the average speed of an object cannot be changed. But here we mentioned the direction. We cannot mention the direction of the object on the slope. So one of the other quantity was that velocity. Velocity on the slope we can take only slope of the object. But what is the direction of the object at any point? How to be drawn? So at any point on the slope, how to be mentioned means we should draw tangent on the curve. Now it is a motion of the object. At this point I want to take the direction of object. How do we? At this point I can draw tangent. What is meant by tangent? At any point on the curve we should draw perpendicular line to its assuming center. It is a tangent and it gives us a direction of velocity. This speed and velocity can be having same type of unit. What average speed? What is the unit? Kilometer per hour and meter per second. So here also speed and velocity, these two are the quantities having the units kilometer per hour or meter per second. And speed is a scalar quantity. Vector is a vector quantity is nothing but velocity. Based on velocity, we have two type of motions. First one is uniform motion and the other one is a non-uniform motion. When we observe in our textbook, one of the activity given, a cyclist covering equal distances in equal intervals of time. Nothing but he started his journey from 0 second, and first second he covered 4 meters and the second he covered again 4 meters. Nothing but total in 2 seconds how much distance he covered? 8 meters. And third second also he covered 4 meters. Up to the 3 seconds he covered 12 meters. So like this we plotted a graph between the distance and time. And what type of graph we got here? The shape of the graph is linear for uniform motion. So here equal distances covering in equal intervals of time. And one of the other point is what? Instantaneous speed is equal to average speed of the object in the uniform motion. It is the most important point. What is that? The instantaneous speed of the object is equal to the average speed of the object. And once here, one of the problem he given in our textbook. What is that? One of the man he stood in below of the street lamp. What is the height of the man? Small h. And what is the total height of the street lamp? H. He covered some distance from point O to B dash. The man covered some distance. What is that? Small s. And at the same time, his shadow covering the distance from O to C. What is the total distance covered by the shadow? Capital S. And why I mentioned here small s and capital S? But in our textbook also he mentioned small s and capital. That's why here small s is nothing but the distance covered by the man, and the capital S is nothing but the distance covered by the shadow. Here the height of the man is small h. Here two similar triangles we can observe. What are those? A, B, D. The other one is A, C, O. A, B, D and A, C, O. These two are the similar triangles. And where the two similar triangles we are having, the ratio of sides are equal. So DB by AD equal to OC by AO. Then substitute the values. So what is the DB value here? It is the parallel side of OB dash. So OB dash is smallest. So same as DB also smallest. And what is the AD? Capital H minus small h. Then OC value. What is the distance covered by the shadow? Capital S. And what is the AO? Street lamp height is capital H. By solving of this cross multiplication here, and by using of S equal to V into T, nothing but speed equal to distance by time. Distance equal to speed into time. Substituting values S nothing but small v into T. Finally we got here capital V is nothing but what is the speed of shadow, and small v nothing but what is the speed of man. Finally we got capital V equal to HV by H minus H. This is a problem he given in our textbook. And the other one is non-uniform motion. Non-uniform motion, and here where the velocity of the object is changing. Where the velocity of the object is changing. Velocity is nothing but it is a vector quantity. It has the speed is the magnitude and as well as direction. And what type of graph we may get means non-linear. The graph of uniform is linear. The graph of non-uniform is non-linear. So unequal distances, nothing but a cyclist he covered from 0 second. In first second he covered 3 meters. In second he covered 5 meters. Like that, nothing but he may decrease his speed or increase his speed. So unequal distances covering in equal intervals of time. It is nothing but non-uniform motion. It depends on the velocity. So here he given 3 type of activities. First one, when we observe any object thrown on the inclined plane, gradually increases its speed or gradually decreases its speed when it is moving upside. But here what is the changing? The direction of the object is changing. Direction of the object is changing and the speed of the object also changing. So in the first example we observe in the inclined plane speed is changing and direction is constant. Why the direction is constant? It is moving on the inclined plane. And the second one, when we wind a stone to the thread and tie up and just once you imagine it is rotating, then the direction is changing continuously. Why? Because when we consider it is in a circle position, every point it is changing its position. How do we get the direction of the tangent where we drawn at that point? So in the second example, the speed is constant but the direction is changing. In the third example, when we throw a stone into the air and how the position means it is parabola. At every point changes its speed and changes its direction also. So by the 3 examples, the first one is direction is constant but velocity speed is changing. In the second one, speed is constant but the direction is changing. In the third example, speed as well as direction both are changing. So finally, in these 3 examples, velocity is not constant. So where the velocity is changing, that type of motion is called non-uniform motion. So we can discuss in the next class.